Morning children. So in the previous lesson we have seen Earth is more spherical in shape, and earlier people believed Earth as a flat body. There were people like Copernicus, then Galileo Galilei, who tried to prove Earth is a round in shape. Ferdinand Magellan was a Portuguese sailor who sailed from Spain across the world, and he took around 3 years time for his team to complete the journey and make it as a proof that Earth is a round in shape. Then the astronauts and the people like Neil Armstrong and Edwin Aldrin, who went to the moon, and the astronauts who go to the space have taken photographs from the moon, and it also proved that Earth is round in shape. Okay, so let us consider this as a Earth. Let us consider that as a Earth. Now, on this Earth, we have 2 points. 1, 2. Right? So this is on the top part and this is the bottom part. Or this is called the North Pole and this is called the South Pole. Okay? This is called the North Pole and this is called the South Pole. Right? There is a line. There is a line that passes through the center of the Earth. Okay, see, this North Pole is an imaginary point, South Pole is also an imaginary point, and these are imaginary lines. Imaginary lines means they are not actually there on that, but when we make a globe or draw a map, we use these kinds of techniques. Okay, so we draw a line which divides Earth into 2 equal parts. 2 equal parts, and this line is called equator. Right? So this line that divides Earth into 2 equal parts is called the equator. Now, this line divides Earth into 2 equal parts. Which are they? This is 1, this is a 2, isn't it? Right? So this is to the north of equator, this is to the south of equator, is it? This is on the north of equator, this is to the south of equator. So as this is to the north of equator, we call this northern hemisphere. Northern hemisphere, and this to the south of the equator is called southern hemisphere. Right? So the part of Earth to the north of equator is called the northern hemisphere. The part of the Earth to the south of equator is called the southern hemisphere. Hemisphere means half of a sphere. So the entire Earth is a spherical shape, right? So it's a sphere. So it is half. Okay? So this is a half, this is another half, the second half. That's why they are known as a hemisphere. So the northern part is called the northern hemisphere and the southern part is called the southern hemisphere. When we observe the globe or the map, we can see a lot of continents are basically in this part. Okay, Asia is in the northern hemisphere, North America is in northern hemisphere, then Europe is in northern hemisphere, a good part of Africa and South America also is in the northern hemisphere. Okay, so as there are more land in the northern hemisphere, the northern hemisphere is also known as a land hemisphere. It is also called the land hemisphere, and this part, the southern hemisphere, is more of oceans. So that is also known as a ocean hemisphere. Right? So northern hemisphere has most of the continents of the earth, and that is why it is called the land hemisphere. And southern hemisphere has most of the oceans of the world, and that is why it is known as a water hemisphere. Okay, that is land, and this is not ocean, it is a water hemisphere. Right? So northern hemisphere is known as a land hemisphere because it has most of the continental part of the world, the earth. The southern hemisphere is known as the water hemisphere because it has most of the ocean part of the world. Right? So in this part, we are going to learn about the different movements of the earth. So earth as a planet has got two types of movements. First is called rotation, and the second is called revolution. So we will see them one by one, right? So as we saw, this is a model of the earth, and there is a north pole and a south pole, and there is an imaginary axis. There is an imaginary axis which passes through the north pole and the south pole on which the earth rotates. Okay, so the movement of the earth on its own axis is called rotation. But as far as the earth is concerned, when it comes to the movement, rotation, we need to consider the north pole not exactly on the top, and this, it has got a 66.5 degree angulation. It comes like this. Okay, so it comes like this. Right? So this is the angle. This is the angle in which we have this axis, and on this axis the earth moves from west to east. Okay, in this direction. Right? So the movement of the earth on its axis, which is tilted by 66.5 degree. This is 90 degree, na? This is a 66.5 degree. Right? So the axis which is tilted to a 66.5 degree is on which the earth has its first movement, and that is called rotation. The rotation of the earth is actually from west to east. Okay, and the time taken for one complete revolution is rotation is 24 hours. The time taken for one complete rotation is 24 hours, and that is what we call as one day. Okay, so the time taken for the earth to complete one rotation is simply one day, which has got 24 hours in that. Okay, so this is because of this rotation of this earth, some part of the earth gets sunlight and other parts darkness. Okay, so the day and night is actually formed because of this particular movement of the earth called the rotation. Right? So days and nights are formed because of the rotation movement of the earth, because when the earth rotates, what happens is if the sun is located here, the sun rays comes out of here, it falls on the earth, and this part of the earth will receive the sunlight, and that part is known as a day, and the other part which doesn't receive the sunlight is known as a night. Okay, so the total duration taken by the earth to complete one particular rotation is 24 hours, or that is called 1 day. So the rotation of the earth is happening on an imaginary line that connects or pass through the north pole and the south pole, that is called the axis, and it is tilted by 66.5 degree to the east. Right? Now, the second movement of the earth is called a revolution. So as we know, as the earth rotates on its own axis, it has another movement around the sun also, isn't it? So imagine this is the sun and this is the earth. Okay, so the earth, as it rotates on its own axis, the earth moves around the sun also. Right? So this movement of the earth around the sun is called a revolution. Right? The movement of the earth on its own axis is called a rotation. The movement of the earth around the sun is called a revolution. And the time taken to and the direction is again from west to east. Right? Now, the time taken for one complete revolution is 365 days and 6 hours. Right? For the earth to complete one particular revolution, to come back to the same place where it was earlier, it takes 365 days and 6 hours. So once in 4 years, what happens is, so 365.6, 365.6, 365.6 and 365.6. So now here what happens is, this become 1 day, isn't it? 24 hours is 1 day. Okay, so usually what we calculate is, we consider 365 days in a year, and on the 4th year, this day will be added. Means this 18 hours in the previous 3 years will be added here, and then we get a leap year. Okay, right? So the total time taken for a revolution to complete it is 365 days and 6 hours. So when we calculate this 6 hours together once in 4 years, we will have 1 day extra. That makes it 366, and that is called a leap year. Okay, and which month do we add this particular day? Yeah, it's added to the month of February, right? Okay, now what are the advantages or use that we have with the movement of this earth around the sun? We know day and night is caused because of rotation of the earth, and we have seasons. We have seasons as the earth moves around the sun. Right? So, which are the major seasons that we have? We have summer, we have winter, we have spring, we have autumn. Okay, for the 4 major seasons that we have are summer, winter, spring and autumn. Right? So summer season, winter season, spring season and autumn season are the 4 major seasons that we have, and these seasons are caused because the earth moves around the sun. And at different parts, when we reach, for example, here it's very long, here it will be short, here again the distances change. So because of this changes in the distances that the earth finds itself from the sun, we have different seasons. Okay, so the earth has 2 major movements, rotation and revolution. Rotation is the movement of the earth on its own axis, that is tilted by 66.5 degree to the east. It rotates from west to east. We get days and nights because of that. The total duration for the earth to complete one rotation is 24 hours or 1 day. The second movement of the earth is Revolution. Revolution is the movement of the earth around the sun. It takes 365 days and 6 hours to complete one revolution. This 6 hours every year is calculated as one single day in every 4 years. And when we calculate in that way, we get 1 day extra on every 4th year. We call that a leap year, and this day will be added to the month of February, which makes it to have 29 days. So, the revolution of the earth causes seasons. The major seasons that we have are summer, winter, spring and autumn. Okay. So, the next is some lines that we draw on the globe. Some imaginary lines known as latitudes and longitudes. So in the beginning we have seen that the North Pole and the South Pole. Okay, so there are two polar regions here. This is called the North Pole and this is called the South Pole, and there is an imaginary line that passes through the center of the earth. We call it the equator. Right? So there are some more lines that runs parallel to this, and they are okay, and there are some other lines also which comes from pole to pole. Okay, so these are the two types of lines that we draw on the earth, and this is the line that passes the center of the earth, that is called the equator, and these lines are called the latitudes. Okay, the lines that run from pole to pole are known as the longitudes. Okay, so equator are lines that run parallel from pole to pole. Means here we have a line, and to parallel to that there is another line, there is another line to its parallel. It goes on like that, okay? They are known as latitudes or parallels. Right? The other longitudes, they start from the North Pole and end from the South Pole. Every longitude starts from the North Pole and end at the South Pole, and they are also known as meridians. Okay, so latitudes are also known as parallels. Longitudes are also known as meridians. Right? So the lines that run parallel from North Pole till the South Pole are known as the latitudes, and the lines that starts from North Pole to the South Pole is called longitudes. Latitudes are also known as the parallels. Longitudes are also known as the meridians. Right? So now we will do it a bit in detail about both the longitudes and latitudes. Okay? So equator is the most important of all latitude. Equator is the most important of all latitude. That is known as the 0 degree latitude. Okay? So from here, North Pole is 90 degree north, South Pole is 90 degree south. So from equator, which is a 0 degree latitude, for every degree there is a parallel running until the North Pole and until the South Pole. So we have 90 parallels in the northern hemisphere and 90 parallels in the southern hemisphere. As all these lines run parallel to each other without touching anywhere, they are known as parallels. Okay? So they do never touch each other. Latitudes will never touch each other. The total number of latitudes we have on the earth is 181, including the equator. Right? So, there are 90 in the northern hemisphere and 90 in the southern hemisphere. We want to consider all these lines, but both in the northern and southern hemisphere, some latitudes are important and some are not that important. Okay? So, both in the northern hemisphere and the southern hemisphere, we have some important and some unimportant things. So, which are the important latitudes? (66.5° north) is one. The second is 23.5° north. 23.5° south and 66.5° south. This is 0°. Okay, so these are the major parallels or latitudes. Okay, so 66.5° north latitude, 23.5° north latitude, 0° latitude, 23.5° south latitude, 66.5° south latitude. So this 66.5° north latitude is known as the Arctic Circle. Okay, so the 66.5° north latitude is known as the Arctic Circle. Right? 66.5° north latitude is known as the Arctic Circle. The 23.5° north latitude is known as the Tropic of Cancer. Okay, they are known as the tropical regions. Right? So, 23.5° north latitude is known as the Tropic of Cancer. Now we have the 0° one, that is the equator. Then 23.5° south latitude is known as the Tropic of Capricorn. Tropic of Capricorn. And the 66.5° south latitude is known as the Antarctic Circle. Okay, so these are the major latitudes we have on the earth, right? The most important is equator, which is a 0° latitude. 23.5° north latitude is known as the Tropic of Cancer. 66.5° north latitude is known as the Arctic Circle. 23.5° south latitude is known as the Tropic of Capricorn, and 66.5° south latitude is known as the Antarctic Circle. Right? So have a look at this diagram and observe it carefully. So the other set of lines that we have on the earth is the lines that runs from pole to pole, that originates at the north pole and ends at the south pole, like this one. It goes on like this, okay? So they start from the north pole and ends at the south pole. When we consider on the top pole, if this is north pole, there will be lines starting at every degree, and we have 360 such lines running from north pole to the south pole. Okay, these lines are known as longitudes. Okay, these lines are known as longitudes, so these lines are also known as meridians. Right? So in this, the 0 degree longitude is known as the 0 degree longitude is known as a prime meridian. Prime meridian or the Greenwich meridian. The prime meridian or the Greenwich meridian, because it actually passes through Europe, and there is a place called Greenwich near London, through which this line passes. Okay, so that is why this is known as a Greenwich meridian or the 0 meridian, and from here this is considered as the eastern part and this is considered as the western part. Okay, so the lines that starts from the north pole to the south pole are known as longitudes. They are 360 in number. They are also known as meridians. The 0 degree meridian or the 0 degree longitude is a line that passes through Greenwich, right? And yeah, there are 180. There are 180 longitudes to the east of 0 meridian and 180 to the west, right? So this east and west directions and meridians are basically used for time calculation. Okay, we use prime meridians or the meridians or the longitudes basically for time calculation. So in the year 1984, sorry, in the year 1884, okay, in the year 1884, there was a conference, an international conference was held at Washington DC. Washington DC. Do you know where Washington DC is? Yeah, Washington DC is actually the capital of United States of America. Washington DC is the capital of United States of America. There happened an international conference in 1884, and it was about deciding the time around the globe. So in this conference, what they have decided is the 180 degree meridian. Means the one that falls, if this is the 0 degree meridian, the opposite one, right? If this is the 0 degree meridian, the Greenwich meridian, when we look from the top of it, we can find another line going on the opposite side of it, isn't it? That is the 180 degree meridian. That is considered as the 180 degree meridian is considered as a international timeline. Okay, it's not timeline, it's a date line. Sorry. International timeline is Greenwich meridian. Okay, so 0 degree longitude is a timeline and 180 degree longitude is a date line. For example, imagine this is the 180 degree meridian. Okay, on Monday, and when you cover this, it comes as if this is USA region and this is Asia region. There's a line falls exactly in between these two regions. Right? So, on Monday you started and Monday itself you crossed this line. But once when you cross this line, you have to change yourself to Tuesday. Means the time, the date has to be changed into Tuesday. Imagine on Saturday you started from Asia. Okay, and by Saturday noon itself you have crossed this line. But what happens? You reaches here on a Friday. Okay, so international timeline is adjusted in such a way that the entire time zones will not get collapsed. Okay, so 180-degree meridian is known as the international date line. Clear? So meridians are other names of longitudes. Longitudes starts from the north pole to south pole. There are 360 meridians around the globe, and 0-degree longitude is known as a prime meridian, which passes through the place called Greenwich near London in England. That is known as the international time line. The time at different places is calculated based on this line. Okay, then in 1884 there was an international conference happened that in Washington DC, the capital of United States of America. It was about deciding an international date line. So the line opposite to this 0-degree longitude, which becomes a 180-degree longitude on the other side of the globe, is considered as an international date line, and it is considered the Asia and American regions have got a day's difference when we calculate it based on the time. Right? So 180-degree meridian is known as the international date line. 0-degree longitude of the prime meridian on the Greenwich meridian is called the international time line. Right? So we have seen the two types of lines that we have on this earth. The parallels are also known as the latitudes, and the meridians or the longitudes. Okay, so when you observe the globe or a map, we can see these kinds of lines crossing over that. Right? And this actually forms a formation called the grid. A grid formation. Okay? The latitudes and the longitudes together form a grid formation, and this grid formation actually helps us in identifying different places. For example, it says 19-degree north, 73-degree east. Yes. Okay, so what we need to do is, we need to check 19-degree north. North means parallels. Means this north and the south always comes on latitudes. And east and west comes on longitudes. Okay, so when we see this thing, the 19-degree north, we need to check the parallels. So this is 0 and here is a 19-degree. Right? Now we need to check 73-degree east. So this is a 0-degree, and yes, here it comes. So when we cross check this particular point where the latitude and the longitude meets, This is what is a 19° north and 73° east. And when we check this particular location on a map, we can see a place over there, and that is Mumbai. Right? So if we have to locate different places on this earth, we make this a grid combination formed by the latitudes and longitudes. Okay? So a combination of, there is no other place in this world which can come on this particular latitude-longitude combination. Right? On this grid combination, there is no other place on this world can come over there. Okay, so this grid system that is formed by the latitudes and longitudes actually helps us to form a grid combination with which we can easily identify the location of different places. Right? So that is for the lesson part, and in the next class we will deal with the exercises or activities from this lesson. Okay, so till then, take care.